Let's look at some free response questions that have to do with curve sketching or the features of the graph of a function. So we have, first of all, a function here, f of x equals e to the x cosine x. And we want to find the average rate of change. Don't get this confused with the average value. Average value has to do with integrals. And the average rate of change is just a secant line, right? The slope of the secant line. So it's just slope. So average rate of change is slope. So we have y2 minus y1 over x2 minus x1, all right? So we have f of pi minus f of 0 all over pi minus 0. And this you can say is delta y over delta x. That's the average rate of change. So I'll plug these in, and we have e to the pi cosine pi minus e to the 0 cosine 0 all over pi. And there it is. You don't have to go any further. So the requirements of the AP exam do not require simplification. In fact, it's a good idea not to because you might make mistakes. So this is we do have to substitute the pi and the 0, but we don't have to simplify. Now, if you want to, and it's an easy and safe simplification, you can. We do know the cosine of pi. We should know cosine of pi is 1. Actually, negative 1. And e to the 0 is 1. Anything to the 0 is 1. Cosine of 0 is 1, positive 1. So this is 1 all over pi. So that would be a good answer there. This is a no calculator problem, so we're not expected to get a decimal. We wouldn't necessarily need one anyways if it was a calculator problem. So now, what is the slope of a line tangent to the graph at x equals 3 pi over 2? So slope of a line tangent. So we should be saying, all right, slope of a tangent line, that's the derivative of f there. We'll find our slope. So we need f prime of x. And that is, we're going to have a product rule there. So derivative of the first times the second. Derivative of the first is e to the x times the second, which stays cosine x, plus the first times the derivative of cosine, which is negative sine x. And so we'll put our negative out here. All right. Now let's evaluate f prime of 3 pi over 2 equals e to the 3 pi over 2 times the cosine of 3 pi over 2 minus e to the 3 pi over 2 times the sine of 3 pi over 2. All right. Do be careful. My 3 pi over 2 here doesn't quite look like an exponent, so I'll have to write neatly in my next step here. I'm going to go ahead and similar to the next one, you could probably leave it that way, and you would get credit for it there. But good idea to go ahead and evaluate the sine and cosines, the trig functions there. So cosine of 3 pi over 2, 3 pi over 2, this is my little unit circle just for reference. 3 pi over 2 is down here. Cosine is 0. So this guy is going to be 0 times e to 3 pi over 2. Sine of 3 pi over 2 is negative 1. So this will be negative 1 times negative e to the 3 pi over 2, which is positive e to the 3 pi over 2. Now notice, let's go back and look at the question here. always good practice, by the way. Always look back at the question, and we are finding the slope of the tangent line. We're not looking for the equation of the tangent line. That'll be another question that will be asked. If we wanted the equation, we would write this in point slope form. It'd be y minus y1, and we'd have to actually plug this into the function and figure out what f of 3 pi over 2 is. So we use point slope form, y minus y1 equals m times x minus x1. That would be the equation, but we don't need the whole equation here. So the next question here, we're looking for an absolute minimum of minimum value. Now we could graph this function, but even if we did have a calculator, that might take a little extra time that we don't need. Remember that the minimum value or the extrema happen when f prime equals 0, all right? So f prime of x equals 0. Anytime you have a extrema question, we're looking for minimum or maximum. It's a good idea to write that down right away. Keep in mind what you're doing, all right? Write down the concept here. We wanted the average rate of change. Write that down right away. Here we wanted the slope of the tangent line, f prime of x. Write that down right away. Don't jump to the answer. There's points for understanding the concept and knowing what we're looking for. So those things right there are very useful, very important. One, they keep you on track as far as what you need to do. And two, they very often will get you points on the AP test, all right? They show understanding. Now, f prime of x equals 0, so we need to find f prime of x. We kind of already did here. So we found that. And so we can use that. We want to set that equal to 0. So we have e to the x cosine x minus e to the x sine x equals 0. Okay, and so we need to solve this here. Might be tempting to divide out e to the x here, but better to say this, e to the x to factor it. Now in this case, we can divide. You want to be careful dividing by 0 or anything that has to do with 0, because if this, you don't want to divide by anything that has to do with x. Okay, so e to the x. If you divide both sides by e to the x to try to get rid of it, then yeah, you would get rid of it. But if this thing can ever be 0, then you have a problem. So better to factor it. Let's use our 0 product rule. We have two things multiplied to 0. So what makes this 0? Well, will this part ever be 0? E to the x, we got to remember something about the graph of e to the x. It's a exponential graph like that. It'll never be 0, right? So e to the x cannot be 0, but this part can be 0. So sine x has to be equal to cosine x, right? So we have cosine x minus sine x equals 0, and so cosine x equals sine x. And that's going to happen at a few points. So think about our unit circle. Where is sine and cosine exactly the same? Well, right here, they're both pi over 2, right? They're both root 2 over 2, right? So that's at pi over 4. And then down here, this is negative root 2 over 2 and negative root 2 over 2. So there's two places, and that's at pi over 4. And this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, so at 5 pi over 4. Now, we got to remember when we're looking for an absolute minimum or maximum on a interval, we got to check the two endpoints, 0 and 2 pi. So we're going to have to check these out. So I'm going to make a little table of values, which is what I'm building here. X and f of x. So we'll remember our function is e to the x cosine x. So we'll plug in 0. Cosine of 0 is 1. E to the 0 is 1. So this is 1. Plug in pi over 4. And we're going to get e to the pi over 4. You might be saying, no, this is a non-calculator problem. Well, yeah, we'll deal with that in a second. So root 2 over 2, that's cosine of pi over 4 is root 2 over 2. Okay. Cosine of 5 pi over 4 will be negative root 2 over 2 times e to the pi over 4. 5 pi over 4, that is. And then last but not least, we plug in 2 pi. 2 pi is, again, 0. I'm sorry, it's 1. It's the same as 0. And we get e to the 2 pi. So e to the 2 pi times 1, which is 1. All right, so we are looking for a minimum value, okay? And this is a no calculator problem. And we don't even necessarily need a calculator for it, as you'll see. So 1 is 1. Okay, is this bigger or smaller than 1? Well, let's see. Root 2 over 2. Well, the key is it's positive. Okay, we don't need to think too much about this. Root 2 over 2 is 1.4 about, so this is like 0.7 times e to the 3/4. And so, yeah, it's positive. This guy is negative. We're looking for the smallest value. This is the only negative number. This is positive, positive, positive. This is negative. So this is clearly the lowest or the minimum value. So the answer is 5 pi over 4 is where it is. And the question, let's look back at the question. We want to find the absolute minimum value. So the minimum value is that thing in blue here. So we can say the absolute minimum equals negative root 2 over 2 times e to the 5 pi over 4. That's the lowest value. We don't need to evaluate it, of course. That's just fine. There it is. Okay, so but remember, when we're looking for min or max on an interval, we have to actually find where f prime of x equals 0 and check the endpoints. Okay. All right. Last one here. We got let g be differential function. G of x. I'm sorry. G of pi over 2 equals 0. Here's the graph of g prime down here, the derivative of g. And we want to find the value that is a limit. Oh, interesting. Okay. So lots of things going on here. We got a graph, f of x, which is from up above. Okay. And then we got something about a limit. Okay. So we've got our limit as x goes to pi over 2. And of f of x and over g of x. Now, if we think back to our study of limits, we had a few ways to simplify limits. We had limits where they were polynomials that we could factor. So we tried to factor the top and bottom and cancel things out. We had limits where we had radicals, square roots on the top and bottom. And we had to rationalize the numerator or denominator. We had compound fractions where we had to simplify it to a non-compound fraction. But none of that has anything to do with this. I don't know. Well, we do know the equation for f of x. It's what we had up above here. It's e to the x cosine x. But we don't know the equation for g of x. We've got this graph of g prime, but it's piecewise. There's no way to figure out this equation. So what we need to do is take a clue from the fact that this is a derivative. And so by L'Hopital's rule, this is equal to the limit of as x goes to pi over 2 of f prime of x over g prime of x. Okay, so we can say that's by L'Hopital's rule. And that's exactly what you're being tested on. Do you know that a limit can be found by L'Hopital's rule here. And so the limits, we know this, f prime of x is what's given to us there. I'll write it out. Again, we don't know the derivative. We don't know the equation of g prime of x. So we're being asked to show that we can find the limit of the top over the bottom. Okay, so the limit of the top, what is the top going to? We've evaluated this for a few values up here, but we haven't evaluated for pi over 2, so we're just going to plug that in. We get cosine of pi over 2 is 0, so this becomes 0. Sine of pi over 2 is 1. And e to the pi over 2 is e to the pi over 2. So this becomes negative e to the pi over 2. And we can evaluate g prime of x just by looking at the graph. What is the limit of g prime of x? Got to make sure it exists. Remember, when you're looking at a limit of the graph, it's got to be going from both ways there, okay? So they're both approaching the y value of 2. So the limit of g of the function g as we go to pi over 2 is 2. Okay, so over 2. And that's it. So, all right. So use those clues. L'Hopital's rule will very likely show up in some way. Okay, that's our most powerful tool for evaluating limits, but we have other techniques as well. So, all right, so that took us, talking about it takes about 16 minutes. Goal is 15 minutes. So if I didn't waste all this time talking, didn't spend all this time talking, then yeah, that's about a 15-minute problem there. So that's your goal. So, all right, great. Keep working on it, and remember those important things about the features of a graph that would help us sketch the curves, or at least understand what the graph looks like. So, all right, good luck.